thank you so much for taking the time and accepting our invitation to present. It's a great pleasure to have today the joint paper by Melina and Papageorgiou, if I got that right. In a sense, the reason why this paper looked interesting when I read it was because certain types of shocks might in nature have some similarity to what we're facing. So, for example, the loss of access to the sea for a short period of time can be considered a flooding, or the incapacitation of critical infrastructure and so on and so forth. So obviously we're looking at this from various angles, but I think there might be something useful and applicable, which is why I'm really happy that we're able to see this paper today. So we usually take about an hour. We take quick clarification questions during the seminar, and any things that are more complex, we leave it for discussion towards the end.
All right. Great. Thanks so much. So I'll take it from here. Giovanni will do the presentation. I'll set the context. First of all, I'd like to thank you guys for inviting us. We are pleased and humbled to be here with you. I was surprised with Giovanni that you requested us to present this work, but the more we thought about this, we got exactly to the same conclusion that this could be very relevant because, as I will also set the context on these shocks, they are very similar to other shocks, right? It's just that they have some specificities that we are new to this, right? We are climate macro is a new field, but as we discover more about what these shocks are, you are right, they may be very close to other shocks that we consider. And then we can also set the discussion in the end, if you'd like, from that perspective as well. But just to set the context, I think it's good to go back maybe 5 years when, places like the fund, other international organizations were completely out of this game of macroclimate. It's only over the last 5 years that it has become such an important issue, and in the right way, in the sense that for many years, environmentalists have warned us. We knew that there is this very long-term uncertainty, but in our macro frameworks was indicated like, minimally in the very long term, right? Something happens to growth in the very long term. Over the last 5 years, I think it became clear to macroeconomists that this is not only an existential issue, it's very much a macro issue. And it's an issue for the medium term, and usually issues of mitigation, right? Like how do we reduce temperatures or CO2 emissions? But it's also very much an issue of adaptation, which is the shocks that we'll talk about today, right? The natural disaster type shocks, which we can extend. We can start thinking more broadly, right? Like how this could impact the macro framework. So once this kind of became clear to macroeconomists, then it was easier for us to map it to models, right? Macro models we know well, and then have an anchor over which we can investigate these shocks. So again, 5 years ago, the fund started this work. Some of the work has nothing to do with what we will talk today. It's about DSG models looking at the very long-term models of mitigation. What we will talk about today are models on adaptation. How do you adapt to these big shocks we call natural disasters? In our minds, it's tornadoes, whatever shocks, natural disaster shocks you have in mind. But by extension, we can also think about them as shocks that are very actually similar to other shocks, and I'll talk about this in a minute, that we are very good at, that we have been looking for a long time. So Giovanni and myself and a team of us in the research department specialized on the adaptation side of climate. And we developed some models, and it's interesting to know a little bit about the evolution of this, because you'll appreciate how novice we are on this, right? So when we started this work, the critical issue was the fiscal side, right? So you have a shock hitting, then the question is, the immediate impact is large. How do fiscal authorities, right, react to such thing? And then we have a paper on this, focused entirely on, policies that come from ministries, right? From the fiscal authorities, the fiscal impact. And we thought that's the end of it in some ways, right? Like other fiscal shocks. But as we took that model to the ground, we went on missions, we talked to authorities and so forth that were going through these natural disasters. We noticed that this is as big of a problem for central banks as it is for physical authorities, right? Because imagine sitting you are a central bank governor, you are hit by one of these shocks, you immediately think adjustment. And you are thinking about it in two dimensions. What do I do now to mitigate the issue, right? But how do I get out of it as well? Because by doing things now, I also have to be thinking, how do I get out? And I have to be thinking about the inflationary pressures of whatever I do, whatever policies, easing policies I have in mind. And in fact, we've seen this on the ground, right? We have now programs and experience where a country was hit with these big natural disasters, immediately is a fiscal problem, very soon become a central bank problem because immediately the bank jumps in to solve the problem, right? And then it becomes an even bigger problem later on because we have to exit, whatever easing was done, and we don't know when to exit. And in fact, our policies in the fund were not clear because we considered these shocks just recently. So I wanted to say one more thing because I leave it to Giovanni on the presentation. I think it goes back to what we have been talking about as the shock. So at the beginning, we were a little puzzled about these shocks, right? What are these shocks? How we were thinking about them as exotic shocks, right? Natural disasters. We were saying we are not environmentalists. We need to know the science. But bottom line, after 5 years of work, we recognize that these shocks are not very different than any other macro shock we are very good at analyzing. So think, for example, an oil shock, right? That we are very good at. I mean, Macro 101, oil shocks, we have many papers written with all the oil shocks happened in the past. We are very good at analyzing them in a DSG framework. And we are finding out actually that these types of shocks are not very different in nature than the oil shocks, right? Basically, all the conceptual thinking we have been doing in terms of fiscal and monetary policies on oil shocks apply to these shocks. So then all of a sudden it became much easier to internalize these shocks in the models that we know very well. And with that, let me pass it over to Giovanni. Giovanni?
Thank you, Chris, and thank you, colleagues from the National Bank of Ukraine for the invitation. And thanks to Chris for providing all the context. So now I will focus on this specific paper in my presentation. You can see my slides, right? Yeah. Okay. Perfect. In this paper, we want to provide answers to. Oh, I'm sorry. I have all of a sudden an error message related to a license, but anyway. So we want to provide answers. I'm very sorry, I'm facing some issues with my computer. So we want to assess whether climate-related natural disasters significantly weigh on the development path of disaster-prone emerging and developing economies. And second, we want to check to what extent climate change may affect their macroeconomic outcomes and their welfare. And third, we want to evaluate how policies could mitigate these effects. In this paper, essentially, we do 4 things. Using the so-called EM-DAT dataset, we build stylized facts on both frequency and impact of natural disasters based on a sample of 132 emerging and developing economies. We use these stylized facts to calibrate disaster shocks in a DSG model that I will talk about in a few minutes. Through the lens of the model, we assess macroeconomic and welfare outcomes in disaster-prone countries. And finally, we look at policies. But first, which are the countries that we are talking about? We defined disaster-prone countries as those in the top 25% of the distribution of the annual probability per 1,000 square kilometers of experiencing a natural disaster. And these are mainly small islands located in the Pacific or the Caribbean, or low-income countries, basically countries that are either geographically small or have a small GDP. And this makes them more vulnerable to natural disasters because when a natural disaster occurs, its damages represent a large fraction of their GDP. And importantly, these are countries that have contributed to climate change in a negligible way because their emissions are a tiny part of total global emissions. For simplicity, we call the rest of the countries non-disaster prone. So the first stylized fact I would like to emphasize is that in the distribution of emerging and developing economies, the probability of experiencing a weather-related natural disaster is overwhelmingly skewed. Non-disaster prone countries exhibit probabilities up to 2% on an annual basis. Disaster-prone countries exhibit probability up to 100%, with a large share of them facing probabilities about 40%. Also, disaster-prone countries face much larger damages per disaster as a fraction of GDP. And in some extreme cases, disasters bear damages larger than 50% of their GDP. And the stark difference between the two country groups as regard the magnitude of damages to GDP is largely explained by the size of the economies, as I was saying before. In fact, according to our definition, 74% of disaster-prone countries are what we call small economies, which is the union set, essentially, of low-income countries and small states. Now, the increase in the frequency and magnitude of natural disaster in disaster-prone countries has been much more pronounced in the last decade relative to the previous decade. And the frequency increased by 35%, and the average damages to GDP have increased by 82%, likely reflecting a stronger impact of climate change on these countries. And the same statistics have actually marginally decreased in non-disaster-prone countries. If we look at the types of disasters, storms are by far the most disruptive disasters. On average, they cause damages amounting to 12% of GDP in disaster-prone countries. And if we look at the 20 most damaging disasters in the past 20 years, we can see that the majority of them were actually storms. As Chris was saying before, we, as authors of this paper, are not really climate experts. We are macroeconomists. So we see these weather events as shocks that we can incorporate in our models that we know pretty well. And however, a difference relative to other macroeconomic shocks is that these natural disaster shocks can be very large. And so they move the economy from what is known as the steady state of the economy. And when they become as frequent as we saw in the previous slides, their effects may compound because the economy has not recovered from one shock that another shock occurs. And this may lead to permanent effects and also poses challenges not only for the economies, but also for modeling in a DSG context, because standard solution methods such as log linearization, for example, become inaccurate. And if the model is large enough to accommodate at least the minimum set of features to be meaningful, fully nonlinear stochastic solutions are very challenging from a computational point of view. And obviously, nonlinear but perfect foresight methods do not leave room for stochastic shocks by definition. So now let's see how we dealt with these technical issues and how we incorporated our stylized facts in the DSG model. We use a DSG model embedding disaster shocks, and as in the 2018 paper by Fernandez Villaverde and Levinthal, which in turn modeled them along similar lines as in the 2012 AR paper by Gurion. And importantly, this is not a model of climate change. In other words, the frequency and intensity of natural disasters do not depend on the economic activity, given that essentially we are dealing with countries that have a tiny contribution on global emission. And we solved the model with the Taylor projection, which is a solution method that deals effectively with large nonlinearities that are induced by large disaster shocks. And this has been recently popularized by the paper by Fernandez Villaverde and Levinthal. The solution method is a hybrid method that nests Taylor expansions and the projection method, and it assumes that the distribution of disaster shocks is known and their realization is stochastic. Given the large size of these shocks, the stochastic or risky steady state will depend to a large extent on the distribution of the shocks. We calibrate the model to two hypothetical economies, non-disaster prone and a disaster prone countries. And we assume that the two countries are completely symmetric, except for the distribution of natural disasters. And this allows us to isolate their role. And our main contributions relative to the literature are the use of the stochastic setting, which other related models do not account for, the assessment of the effects of disaster shocks in the long run, and on welfare.
Giovanni, I have a very quick question here. So one of the stylized facts you showed us before is the increase in frequency of disastrous events, for at least for those countries. So when this assumption is needed, distribution of disaster shocks is known, does this impact in any way this, prior observation? I mean, do we assume there's an increasing mean over time, an increasing variance?
Right. Yeah, no, this is a very good question. So in the exercises that we do, essentially, this issue of increasing frequency or the increase in intensity and so on and so forth, we do it in like separate simulations. In that, in each set of simulation, there is not a shift in the distribution of disasters. So over time, the distribution stays the same. However, we also do some alternative scenarios where we shift the distribution, but again, within that set of distribution, then the distribution is going to be
okay. And then you compare the impulse responses across the two.
Across the two, yes.
Okay,
yes.
Thanks.
Yeah. No. Okay, so essentially, sorry, I went to the end of the presentation and now my computer seems stuck. I'm very sorry for this.
That's a realization of a not so frequent shock.
Shock, exactly. Okay, so I think I was here. So in a nutshell, we use a model that is very similar again to Fernandez Villaverde and Levinthal. So in the model, there is stochastic trend growth, Epstein-Zinn preferences that are suitable to capture disaster risk, and investment adjustment costs. An important differences relative to this basic setup are that we abstract from nominal rigidities in this paper because our focus is on the long run. We open up the economy in a very stylized way to introduce external government debt. We have a fiscal sector with distortionary taxes and government debt. We allow the government to invest in standard and so-called resilient infrastructure. I will say something more on this concept. And in also international grants that can be injected from abroad in the aftermath of natural disasters to help rebuild resilient infrastructure ex ante. So given that that many of the model features are well known, I will focus on those that are less known. And so let's start from how we introduce disaster shocks in the model. So disaster shocks imply a fall in the stock of capital and in productivity. So in the usual law of motion of private capital, which is equation 1 in the slide, actual capital is the optimally chosen net of disaster shocks, as shown in equation 2. And dt is essentially a dummy variable that takes value 1 if a disaster occurs and 0 otherwise, while variable theta governs the disaster magnitude. And as shown in equation 3, the disaster magnitude is subject to so-called disaster risk shocks that capture not only the uncertainty around the realization of the disaster, but also around the magnitude of the disaster itself. And importantly, disaster risk shocks affect the economy also in the absence of a disaster realization, because agents know that a disaster may take place. As shown in equation 4, TFP follows a unit root and is also affected by disasters in a proportional way. And we calibrate the probability and average magnitude theta bar to match our stylized facts that, as I will show in a minute. So it is also worth reminding that we add the fiscal sector, and in particular investment in public capital, which is also subject to the same disaster shock, and these are equation 5 and 6. And external public debt, which is equation 7, may increase because of investment in standard and adaptation infrastructure, which is in turn is more costly to build, and because of a fall in tax revenues when disasters occur. But in some of our exercises, may kick in when a natural disaster occurs. In addition, the tax rate follows a feedback rule with inertia, which is equation aid also follows a feedback rule, but reacts to disaster shocks when they are activated. And the stock of public capital is given by the sum of standard and adaptation infrastructure, which for simplicity is fully resilient to disaster shocks. But as I mentioned earlier on, it is more costly to build. And standard public capital is replenished by new investment when a natural disaster hits. Now, in the interest of time, I will not go through the whole calibration of the model. I just want to reiterate that we calibrated to 2 hypothetical countries that differ only by the calibration of disaster shocks, which in turn exploits the stylized facts that we report in the first part of the paper. In this way, we isolate the effects of these shocks on macroeconomic outcomes. As you can see, in disaster-prone countries, the probability and mean disaster size are order of magnitudes bigger than in non-disaster-prone countries. And the standard deviation of disaster risk shocks are calibrated to match the dispersion of damages around the mean. So let's see the main model results. These are the impulse response functions to an average one-off natural disaster. And this has obviously a negative effect on GDP, on consumption, on the stock of private and public capital. In contrast, private and public investments increase in order to rebuild the stock of capital. And the public debt ratio increases because of the fall in tax revenues and the increase in investment expenditures, and of course, the GDP denominator effect. Finally, the tax rate responds in order to bring down public debt back to the steady state. Then we overlay these red lines that are essentially impulse response functions to a much larger natural disaster. And we calibrate the intensity in a way to mimic Hurricane Matthew that hit Haiti in 2016. And we can see that not only the size of the responses, but also their persistence increases. However, even if slowly, eventually macroeconomic variables revert back to the balanced growth path. And we need to keep in mind that these are one-off shocks, but as we were saying before, disaster-prone countries are subject to frequent disaster that are sometimes very frequent. So in many cases, a country has not recovered from one disaster, that a new disaster hits. And so the effects of these disasters may compound over time and trigger permanent effects. And this point is shown by this table that is essentially the most important table of the paper. And here we show that only by being subject to more frequent and more powerful natural disasters, disaster-prone countries every year growth on average at a rate almost 1 percentage point lower than non-disaster-prone countries. And this implies that absent policies or other compensatory mechanisms, natural disasters alone may make disaster-prone countries diverge from their peers. And overall, welfare losses are equivalent to a permanent loss in consumption of more than 5% relative to non-disaster-prone countries. Now, scientists agree on the fact that climate change will increase the frequency and intensity of natural disasters down the road, but there is also a lot of uncertainty surrounding these projections. So we conduct a very, very stylized experiment by increasing both the frequency and the magnitude of natural disasters, assuming a surge that is proportional to the one observed over the past 10 years. And under this scenario, the missed GDP growth in disaster-prone countries would be almost 3 times larger. The additional public debt would be more than 7 times larger, while the overall welfare loss would be almost 20%, that is almost 4 times larger. So the bottom line is that climate change is likely to magnify both growth divergence and welfare losses. And finally, let's have a look at policies. First, we look at the role of foreign grants as an ex-post policy. Basically, the government receives an external grant from international donors whenever hit by a natural disaster. And the amount of the grant is proportional to the damage, following the feedback rule I showed earlier on. In this chart, we report welfare gains as a function of the average grant received on a yearly basis. In other words, we simulate the model for many parameter values of the grant feedback rule, and in the simulations, the grant is dispersed each time a disaster occurs. And for reporting purposes, we spread the total amount of grants received during the whole horizon over each year and express it as a share of annual GDP. And the rationale for reporting results in this way is to make the number comparable to the grants that finance resilient investment on a permanent basis, which I will present in a couple of slides. So welfare gains are reported on the y-axis in percent of the baseline welfare loss. That is the welfare loss in the absence of grants. And obviously, welfare monotonically increases in the amount of grants as a percent of GDP. As to close 100% of the welfare loss from natural disasters, on average, each year, grants should be as large as 2.6% of GDP. And to put things in perspective, taking the average GDP of disaster-prone countries, which is approximately the GDP of Haiti, this would amount to $206 million of US dollars every year, not only when natural disaster hits, which is far beyond what is actually disbursed. For example, between 2016 and 2018, Haiti received approximately 53 million per year in aid for Hurricane Matthew, and this included not only grants, but also concessional loans. So alternatively, grants could also be used ex ante to finance public investment in resilient but costlier infrastructure. So we assume that resilient infrastructure is not only destroyed, is not destroyed by natural disasters, but bears an additional fiscal cost. And according to the World Bank, resilient infrastructure is on average 25% more expensive than standard capital. And we conduct a benchmark exercise in which countries self-finance the extra cost of resilience, and an alternative exercise in which donors cover a certain fraction of the extra cost. And in this figure, the top panel shows the case of disaster-prone countries that self-finance investment in resilient capital. In other words, they do not receive any grants. And it turns out that they experience only tiny welfare gains because more taxes are needed to finance it, and they may suffer a welfare loss if they overdo it. The bottom panel shows that if donors bear half, the red line, this is obviously an example, or all of the extra cost of resilient capital, which is the blue line, welfare is always improving in the share of resilient capital. And when the entire cost is covered by grants, the blue line, disaster-prone countries are able to eliminate the welfare losses from natural disasters if the share of the resilient capital is about 70%. Again, let's put this in perspective. This ex-ante policy option would require a grant of about 1% of GDP every year, or $86 million in the case of an average disaster-prone countries. And interestingly, this is less than half of the amount needed for the ex-post policy option. So to conclude, we find that natural disasters may weigh on the development path of disaster-prone countries by permanently keeping growth and welfare lower than in non-disaster-prone countries. And climate change is likely to exacerbate dramatically these effects. In addition, disaster-prone countries cannot increase welfare significantly by investing in resilience on their own. Therefore, international aid is crucial and is more cost-effective when it is granted ex-ante to finance investment in resilient infrastructure rather than ex-post, that is for reconstruction in the aftermath of a disaster. So that's the end of the presentation.
Great, many thanks. I have a quick, actually I have two questions. One related to the choice of leaving out human capital dynamics. Of course, you know, if it's just a bridge or you know, some houses being damaged is one story, but once you have human capital loss, that how does this play in? Did you think about this, or is this of relevance to the current exercise? One of the things I was thinking is, if you remember, at least for the US, when Katrina hit, New Orleans was already facing some issues in terms of population before Katrina because of poor jobs, et cetera, et cetera. So the population was dwindling and actually was very slightly contracting. With this hit, a lot of people never came back. Of course, they had the advantage of being able to relocate inside of the US, et cetera, et cetera. So the second question is thus, you know, there are these relatively large magnitudes. If things start hitting in a climate context, isn't it more welfare enhancing and actually cheaper to simply relocate these people so that they don't suffer these shocks repeatedly?
Yeah, no, these are two excellent questions. The fact that, okay, obviously, as you noted, the model doesn't have human losses, you know, you know, when we thought about this, we looked at some statistics on you know, on natural disasters. Obviously, when big natural disaster happen, there are indeed human losses, but these are still you know, of a small order of magnitude, you know, relative to other damages that you know, that the economy suffers. People are displaced, they lose their home, and so on and so forth. But many of them do not die. However, what we have in the model is is that when a natural disaster hits, not only affect the stock of capital, but also productivity. So to an extent, we also capture the fact that that labor becomes less productive, for example, when a natural disaster hits. And this has also, in the model, has prolonged effect. It has, it is a persistent effect in the model. But it is true, one of the features that is not explicitly modeled is human capital, is not the fact, is also the fact that actually, some of the workers die when there is when a shock hits, and so that affects obviously the economy through that channel as well. So this is a good point. And then in terms of migration, there is a whole literature on the impact of climate change and natural disasters on migration. For example, we can see that there is a literature that says that besides conflict, a lot of the migration that from Africa goes into Europe is due to climate change. Or there are some islands in the Pacific where, as you were rightly noting, they are the population over there is very, very small. So one begin to think whether it could be cost effective to actually migrate the whole country to another country. That is true, although it's not so easy. Also from a political economy point of view, to convince other nations to welcome a whole small island, of people within their borders. So of course, there are these issues, and there is like literature that looks at these issues, but obviously this is not the subject matter of this paper. Yeah.
Okay, sure. Yeah. Many thanks for the clarifications. Any questions maybe from the room? If not, I just have a quick question on your calibration exercise. So I saw an almost 30% drop in GDP when Matthew hit. Do you remember what was the loss in capital that was associated with that? When you overlay the red and the black impulse responses, this one, if I read correctly, no, minus 20% in output, right? I'm not sure I see this.
Yeah. Yes, like so essentially output declined from the initial steady state by 20%, more or less.
Okay,
yes, capital, to be honest, now on the back of my mind, I don't remember the loss of capital that was associated to it, but I can get back to you on that.
That would be good, because actually we have some nowcasting numbers that talk about roughly 25%, and then State Statistics actually just released the number yesterday, and the quarter-on-quarter, if I remember correct, was minus 19, so minus 20, which means that the shock perfectly matches the one you have here. But of course, the question is if we end up with a similar sized shock in capital to explain that we could basically just very much look at your impulse response and get an idea of what we could be facing inside of your model.
Yeah, I can definitely have a look at that.
Yeah,
and let you know.
Many thanks. Perfect. I don't know, further comments maybe, if if not, then thank you so much. It was very, very well structured, and I think the main messages came across very well. I'll just bug you afterwards with some extra questions for slides and some other questions on the exact exercise and so on and so forth. maybe you guys can also guide us a little bit in some of our choices that we're facing, and I'll try to write you an email so that you understand where we are. Many thanks again. Have a nice day and keep in touch.
Thank you so much.
Perfect. Thank you so much for the invitation.
Thank you. Bye.
Yeah.
Bye.
Bye. Bye. See you.
Bye.